Okay, so title this, guys, Production Possibilities, Frontiers, and Sets. So as I said, this is going to be the tools that we need in our toolkit so that we can understand the concepts of trade. And this is not exciting content, so I'm going to apologize. We're going to go through this really quickly, but it's going to get more interesting next class period when we get to start thinking about the idea of trade. All right, so gang, let's start by introducing our first tool. And our first tool is the Production Possibilities Set. The Production Possibilities Set. And you're going to see me abbreviate this as the PPS. So the Production Possibilities Set. We define the Production Possibilities Set. It's basically a graphical structure that's going to show all possible combinations of goods and services that a country can produce. So it shows all possible, underline the all possible combinations of goods and services that a country can produce. So we're going to keep the world very simple. We're going to assume a really simple construct, and that's that we have a world with only two goods. Now, could we do more than two goods? The answer is yes, but it starts getting highly mathematical. So I can show you everything that I want to show you in a simple two-good world. So let's let our goods for right now be goods X and goods Y. So if I want to illustrate the production possibility set, it's very simple. We're going to have a two-dimensional graph. And then, if we want to show the maximum that we can produce of good X, let's say it's right here. So I randomly kind of picked that point, but make sure you understand how we might calculate it. That would be how much X we can produce, if we only produce X. So how much X can we produce if we only produce X? So all of our resources are going into X. And then by the same logic, if we only produce Y, let's say that we would be at a point like that right there. So we're putting all our resources into Y. We're not producing any X. All right. Of course, we can also have some kind of combination of the two. So we might decide to produce some X and some Y. Maybe it's a lot of Y and a little X, or it could be a lot of X and a little Y. But that means that I can take this and connect our two dots. So this is going to show us our production possibilities set. Now when we look at our production possibilities set, guys, you see that there are some places where we're maximizing output. Does everyone agree that this blue point that I've put there, we're maximizing output, right? We can't produce any more than that. We can switch between X and Y, everyone agree? But I can't produce more than that. And do we agree the same thing with this second blue dot? I can switch between X and Y, but I can't produce any more. And same thing with this blue dot. So what that tells us is that there is a set of points along that border that show us maximum output. In other words, at those points, we can't produce any more. But if we wanted, we could increase one and we could decrease the other. So these set of points right here along the border we call our production possibilities frontier. Production possibilities frontier. And you're going to see that abbreviated as PPF. Production possibilities frontier, the PPF. All right, so let's be clear. The production possibilities set is the whole graph, right? The production possibilities frontier is just the border. Everybody with me? All right. And I'm going to not get my graphs too messy, so I'm going to redraw this so we can add on. All right. So we've got our 2 dimensions, bless you, with X and Y. And so far we know that all of this stuff on the border is our PPF, right? But the whole thing is the PPS. Everybody with me there? Now, let's think about the points on the interior. Does everyone agree that the points in here don't show maximum output, right? So do these points seem efficient? Are we maximizing our output? No. What about the points on the PPF? Do they seem efficient? Sure. So the PPF is going to be the set of efficient points because that's where output is maximized. But the points in the interior we would describe as how? We're not maximizing output, so we call them what? They're not efficient, so they're what? Inefficient.
The stuff inside.
So this is going to be the set of inefficient points. Now let's take a look at this for a second. So if we're talking about maximizing output, efficient means we're maximizing output. Does you agree that everything in the interior has to be inefficient, right? Okay, so let's talk for a second about efficiency. So we have 2 requirements for efficiency. We have 2 requirements for efficiency. 2 things have to hold. The first requirement, if we want efficiency, is that all resources are employed. All resources are employed. In other words, none are sitting idle. So the first requirement for efficiency is that all resources are employed. All resources are being used for some productive capacity. No resources are sitting idle. Do you agree with me, guys? If we have idle resources, we have resources that are unemployed, we can't be maximizing output, right? So that's kind of just intuitive, right? If you have resources not employed, you can't be on the PPF, right? But there's a second thing. What if I simply give all of you a job? So you guys in the back row are going to be the ballerinas. You guys in the next row are going to be the construction workers. You guys right here are going to be the athletes. And right here you're going to be the artists. Everyone has a job, right? Raise your hand if you don't have a job. Everyone has a job. Okay. Guys, are we maximizing output this way? We are? How many of you think you're in a job that's perfect for you, where it's your best use of your time? You do? Did I make you a ballerina? Yeah. Excellent. I look forward to it. So guys, how many of you think you are in your job that would reflect your most productive capacity? Anybody? But you all have jobs. And some of you might feel like, I'm in a good job for me. So if I've given everyone a job, then I've checked the box for number 1, right? All resources are employed. But what's the problem?
Are you efficient in that job that
Yeah, you may not be efficient in that job, right? So there has to be more to simply assigning jobs. Think about it. Behind the Iron Curtain, did they just assign everyone jobs? Did everyone have a job? Sure. Do we think about the economies behind the Iron Curtain as being efficient? No, there were huge models of inefficiency, right? So there's got to be more to it. That's where the second criteria comes in. And the second criteria says that resources must be allocated to their most valued use. Resources must be allocated to their most valued use. Resources must be allocated to their most valued use. All right. So everyone has a job, but you're not in your most valued use. So what I need to do is rearrange everyone and decide who would be the best ballerinas, who would be the best artists, who'd be the best teachers, construction workers, athletes, all those things. And when we're all allocated in some way where our productivity is going to be the highest, now we can talk about maximizing output. And guys, capitalism helps do that, right? Think about capitalism. Capitalism doesn't just assign you a job. It allows people to kind of bid for you, right? And think about it. You're in a job and somebody thinks you'd be more valuable in this other industry. They can bid you away. Labor moves to where it's most highly valued. Okay, so then from this information right here, let's see if we can figure out 2 reasons why we might not be on the PPF. So 2 reasons we might not be on the PPF, right? The PPF is efficient, right? So what would be 2 reasons that we wouldn't be on the PPF? In other words, we're looking at reasons for inefficiency. So from this, can we figure out the first one? What's one reason that we might not be on the PPF? Yeah.
Resources are sitting idle.
Yeah, we have idle resources. We have idle resources. Okay, we have idle resources. And then the other one might be, let's say we don't have any idle resources. The other one might be, yeah.
The resources aren't allocated correctly.
Yeah, we're not allocating resources correctly. So we call that resource misallocation. Resource misallocation. So everyone understands this. So for efficiency, back to the left, do you agree both have to be true, right? 1 and 2 have to be true in order for us to have efficiency. But what about to have inefficiency? Do I need both to be true? No, it's simply one or the other. Either one of these things will cause us to have inefficiency. All right, so far so good, right? Nothing's difficult here. It's not interesting either, but it's not exciting, I guarantee that, but it's not particularly hard. Okay, so let's move on just a little bit. Oops, did not mean to do that. Hang on a second. There we go. So back to our graph. So we know we've got inefficient points in the interior. We've got, right, efficient points. Now I want to add one more thing. How would we characterize a point like G? How would we characterize this? So how would we characterize a point outside the PPF? Well, anyone want to take a stab at this? Who wants to tell me about point G?
Is it unrelated?
Unrelated, we're on the right track.
Maybe you just don't have the resources for it.
Ah, it's something I can't produce, right? Does everyone agree we can't produce bundle G, which makes it, as you said, kind of irrelevant, right? So I can't produce bundle G, maybe because I don't have the resources, or I don't have the technology. Good. So bundle G, we would say, is unattainable. So we would say that bundle G is unattainable. Why might it be unattainable? Maybe we don't have enough resources to produce at that level. So our resources in our current stock isn't enough. Maybe our technology isn't advanced enough to get us there. Good. Okay. So we need to be able to identify 3 types of bundles then. Everyone agree? We've said that some bundles are inefficient, and I'm talking about a bundle of goods. Some are efficient, and some are unattainable, right? All right. Everybody with me? So we have 3 kinds of bundles: inefficient, efficient, unattainable, given our current set of resources and technology. Now guys, can PPFs shift? Can PPFs shift? So let's say we've got our graph of goods X and Y. Is there something that might cause the PPF to shift like that? Anything might cause the PPF to shift like that?
Upgraded technology.
Ah, technological advances. Could be about resources, right? New resources are discovered. Maybe we drill for oil and we discover a lot of oil. So we could see PPFs shift out. Usually it's over time. And when you think about it, do you think that PPFs shift out over time for most countries? Do most countries over time have the ability to produce more and more and more? Sure. So when we think about kind of the macroeconomic concept of economic growth, that would be reflected as the PPF shifting out over time. Okay. Oops. Could a PPF shift inward? Could a PPF shift inward, do you think? Scarcity?
Like if you don't have enough resources, like the oil thing, if you
So
run
depletion
out.
of resources,
Yeah.
maybe. Okay, I like that answer. So maybe depletion of resources. So we had timber, we had clean water, we had oil, but now we've literally depleted them and we can't replace them. Okay, well, it might be another thing.
Maybe like a disaster.
Some kind of natural disaster. So, I mean, imagine Puerto Rico. Do you think Puerto Rico's PPF shifted in? I'm guessing so. So we know after Hurricane, what was it, Maria, I think? We probably saw that with Puerto Rico. What else might cause this? What else might cause this? A lack of money? But remember, money's not an economic resource, so we got to be a little careful. It's really easy to always be thinking about money, but money, remember, is a medium of exchange. What about some things that are going on in some countries that divert resources away from productive activities?
War.
Ah, good. War, civil unrest. Good. All right, so PPFs could shift in, right? PPFs could shift in, right? Could we see something like this? Could we see the PPF shift out like that? What might explain this? Yeah.
You get like only resources, but only for that one.
Ah, something that only affects X. So maybe it's some kind of resources that only apply to X. It doesn't affect Y. Or a technological advance in X. So what if we have a technological advance in X, but it doesn't affect Y? Good. All right. So PPFs can definitely shift out over time. Okay. Yeah.
If it shifts inward, is that still considered the PPF shifting? What is it? PPF shifting in over time?
So are you saying
Like
that
the
same
top one.
example? Yeah, so
top,
that
yeah.
same example could be that we have some kind of natural disaster and it doesn't affect our industries that produce Y, but it does affect our industries that produce X. So theoretically, yeah, I mean, we could have that, especially if it's, like in the case of Puerto Rico, it probably affected everything, right? But what if you have a natural disaster that only affects one part of the country, and that happens to be where coffee is grown? Well, it might affect coffee, but it might not have anything to do with bananas produced on the other side of the island. So sure, absolutely. All right. Gosh, I keep doing this wrong. Hold on, sorry. Okay, so back to our PPF. Let's say that we're on point A of our PPF. And if we're on point A of our PPF, do we agree that we have Y 0 units being produced, and we have X 0 units being produced? So for bundle A consists of X 0 and Y 0, right? Now, what happens if I want to produce more X? What happens if I want to produce more X, guys? What if, I'm going to slide along. So let's say I want to produce more X, and I want to operate right here. So I want to produce X1. Everyone agree, for us to be able to produce X1, we have to give up Y. So now I can only produce Y1. Does everyone agree that to produce more X, we must give up Y? Can somebody explain to me why that's the case? Yeah.
You only have a limited number of resources.
I've got a limited amount of resources, okay? So we've got limited resources. And what else do we know about our resources along the PPF? Along the PPF. What do we know about our resources along the PPF, folks? Do I have any extra resources sitting around that I can just put towards more X? No. So along the PPF, what do we know about resources? They're all what? They're all being used, right? All resources are being employed on the PPF. So if we're on the PPF, all of our resources are being used. So I can't simply produce more, right? I have to give up something. So what this tells us is that movement along the PPF has an opportunity cost. Movement along the PPF has an opportunity cost. So we need to know how to calculate it. And it's very simple. If I want to calculate, that should be point B, the opportunity cost of going from A to B, opportunity cost in this case, of x gained. Everyone agree? In this case, we're moving from A to B, so we're gaining x, and we want to know what is the opportunity cost of gaining more x. Well, that's going to be measured in the amount of y foregone, and we're going to do it as a ratio relative to the amount of x gained. So opportunity cost is going to be foregone over gained. Okay? It's always foregone over gained. Now guys, I need to let you know that if you get this backwards, if you get this messed up, everything you do in a trade problem will be wrong. It'll be backwards. So this is kind of our starting point for looking at our trade problems. And you have to be able to calculate opportunity costs. So I suggest that you make a note to yourself, and it's kind of goofy, but this is how I remember it if I ever get myself confused. Alphabetical order. F before G. Then you won't get it backwards. So alphabetical order, foregone over gained. If it's gained over foregone, you've now lost a ton of points because it's all going to be messed up. Yeah?
So even if it's x, it would still be foregone over gained.
Well, if we're looking at the opportunity cost of gaining more x, it's how much y do we give up over x gained.
Okay.
If I'm going in the other direction, it's still how much x do I give up to gain y. It's always foregone over gained. It doesn't matter which direction we're looking in, it's always foregone over gained. Okay? All right, so, oh my gosh, what in the world? You'd think by now I would learn how to do this right, and I get it wrong every time. I hit the wrong button. All right, so let's put some numbers to this. Let's say that we have a PPF, and I'm going to give you points off of a PPF. So let's say we've got bundles or combinations A, B, C, D, E, and F. And let's change it up. Instead of X and Y, let's let it be tanks and wheat. So we've got two goods, tanks and wheat. Combination A is 0 tanks, right? Because we're going to be along only one of the axes, and 18 wheat. So let's say that our PPF looks like this. We've got wheat and we've got tanks. So guys, where's point A? Where's point A? Which axes? Y-axis or X-axis? Everyone agree we're right here. Point A, right? All right, point B is going to be 1 tank and 17 wheat. So do you agree? We've slid around here a little bit. Point C is going to be 2 tanks and 15 wheat. Point D is going to be 3 tanks and 12 wheat. E is going to be 4 tanks and 7 wheat. And F is going to be 5 tanks and 0 wheat. So, where's point F, everybody? Yeah, along the x-axis, right? So this is F. So we have kind of basically A, B, C, D, E, and F, right? So all I've done is I've taken that PPF and I have made it into a table. Nothing different about it, okay? Well, now let's take a look at opportunity cost. So let's create a column so that we can calculate opportunity cost. But what would make most sense? Should we be calculating the opportunity cost of tanks or of wheat? Well, which direction are we moving in? Are we going from A to F or really F to A? What would make more sense? Yeah, really, we're looking at what's the cost of adding a tank and adding another tank and adding another tank, right? So what probably is the easiest thing to do, but you could calculate it the other way too, is to look at the opportunity cost of tanks. So opportunity cost of tanks is going to be wheat foregone over tanks gained. Now guys, does this kind of sound like marginal analysis? It is, because it's really change in wheat over change in tanks, right? All we're doing is calculating a what? What is that the equation for? Delta W, delta T. What does that look like from high school? Okay, but I'm asking, what am I calculating? What is that really calculating? Okay, change in W is rise, and change in tanks is run. Is this sounding familiar? Rise over run. What is this, guys? Give it to me. Yeah, slope. Slope of the PPF. So guys, really all we're doing is calculating the slope of the PPF. Okay, so let's calculate these numbers. Okay, so let's calculate opportunity cost. Remember, guys, when we're calculating opportunity cost, it's when we make a trade-off, right? So we need to go from A to B, and we go from 0 to 1 tanks. So change in tanks is what? 1. We go from 18 to 17 wheat, so the change in wheat is 1, right? So it's kind of basically a negative 1, right? Foregone. So what's the opportunity cost of the first tank? We have 1 wheat is given up to gain 1 tank. So what does the first tank cost, everybody? Yeah. So the first tank has an opportunity cost of 1 wheat. That makes sense to everyone? All right, so now we can look at going from B to C. If we go from B to C, everyone agree, tanks goes up by 1, and wheat changes by what? 2. So now we've got 2 wheat have been given up in order to gain 1 tank. So what does that tell us about the cost of the second tank? The second tank costs us 2 wheat. All right, so take a second and finish that table really quickly and get my opportunity costs. Take another second and finish that up. So guys, as we go from C to D and we gain that third tank, what is our opportunity cost? Everybody, what is it? 3 wheat to get 1 tank. And what about if we go from D to E? We gain 1 more tank. What does it cost us? 5 wheat. Good. And finally, when we go from 4 to 5 tanks, we gain a tank. What does it cost us? 7. Good. All right. So some things that we can observe here. First of all, we see an interesting pattern here. What is that pattern? What is that pattern? Look at. It's what?
The tanks are just decreasing in 1, or increasing.
Okay, so put it into language that makes more sense. What's happening to the opportunity cost? As we want more tanks, what's happening to the opportunity cost? It's continuously what, everyone? Increasing, right? Does everyone agree? So as we add more and more tanks, as we add more and more tanks, the opportunity cost in wheat is going up. Everyone agree with that? As we add more and more tanks, that opportunity cost is getting bigger and bigger and bigger. We call this the law of increasing costs. So this is a phenomenon that we observe in the real world. Now, you need to look at a handout on Canvas, and that handout is going to do a really good job of explaining exactly why that happens. But it has to do with resources. So let's think about it. If we're only producing, let's say we're sitting right here and we're at point A and we're only producing wheat, then everyone's a farmer, right? But now I want to produce a tank. Which kind of farmers do I want to take out of farming and put into tank production? Just any random farmers? Well, everyone's a farmer at point A. Agreed? Everyone's a farmer. But now we are going to war with this other island, and I need some tanks. So do I just want to grab any old farmer? What kind of farmers are going to be most likely going to be able to, what was that?
Wheat farmers?
Well, everyone's a wheat farmer.
Oh,
What is it about those farmers that might make them good at tank production?
maybe if they have like mechanical skills back.
Okay, they've got some kind of mechanical skill, right? They've been working on their own tractors, right? I don't want to just grab any old farmer. I'm going to grab the farmers that are best able to transition. Well, that's great. But what happens when I get down to like this tank right here? I've got 4 tanks and I need one more tank. Now I've got the people with the least technical skills, which means I have to take more of them out of farming. Does that make sense? So I might only need 2 of you to switch to tank production because you're good at technical and mechanical stuff. But by the time I've taken all the ones that have mechanical skills for the next tank, maybe I need 3 of you out of farming. Means more farming is lost. By the time we get to the 5th tank, I've got very few people with mechanical skills, so I'm going to need 6 or 7 of you. We're going to have to give up more and more and more wheat. But read that handout. All right, so let's take this home and connect this to slope. Do we agree that opportunity cost, we said, was what's foregone over what's gained so this, as we've just argued, is a measure of slope. And I know you guys all remember what slope is, but let's take a look at our PPF. So remind me, guys, what is slope? When I'm measuring slope, what am I measuring? I'm measuring what? What's slope?
Like rise over run.
Okay, it's how I calculate it, rise over run, but what is it?
Changing y over the change in x.
Okay, the change in y over the change in x, which is also the same thing you just said, which is an equation. So good, I'm glad you remember how to calculate it, but what is it? I don't understand any math, Dr. Marks, so you're going to have to explain to me what slope is in a way that I can really understand. What's slope? What are we measuring?
Change.
The rate of the change in? Okay, we're on the right track. Well, explain it to me this way. Guys, here's slope at that point, and here's slope at this point. Are they the same?
No.
Which one's bigger?
All right.
The one on the right, right? So this is the bigger slope. So then what is slope measuring? The steepness, right? The steepness is a measure of steepness, right? It's a measure of steepness. So this is the smaller slope. And to the right, we have a bigger slope. So if I give you a graph like that, shouldn't I be able to conclude just by looking at the slopes that we have increasing opportunity cost? Don't you agree? I don't even need to give you any numbers. I know that that's increasing opportunity cost, right? But what if I gave you, for fun, a problem that looked like this? Maybe I give you constant, something that looks like that. So this might be, to gain the first tank, you give up 10 wheat. You gain a second tank, you give up 10 wheat. Gain a third tank, you give up 10 wheat, right? It's not changing. Everyone agree, when we look at this, we see that the slope, the steepness, isn't changing, right? So this would be an example. We should be able to easily conclude from this that we have constant opportunity cost. Everyone agree with that? I don't even need to give you numbers. And guys, just so you know, for fun, for giggles, I might give you problems where I give you something like this. Now this wouldn't be necessarily realistic in the real world, but I might give you something like that to test your knowledge. What's happening here, guys? Opportunity cost is what? Yeah, so opportunity cost is actually decreasing. So I'm only going to give you something like that kind of for test purposes. Please make a note, this is kind of unrealistic. No one is suggesting that opportunity costs actually decrease. That would be weird. But you could be working with all three shapes. So let's call this shape, we're going to call that bowed outward. We're going to call this shape right here linear. And we're going to call this shape right here bowed inward. All right. So for homework, you're going to need to know these things. One last thing, one last thing. Run out of space. Last thing I want to remind you of is that you always need to reduce over 1. So really quickly, if you say that we have 10 wheat foregone over 20 tanks gained, you need to get in the habit of getting 1 on the bottom. We really want to know what it is per tank. Our opportunity cost here would be 1/2 of a wheat per tank. Does that make sense? So always reduce it so that it's over 1. So you're going to have homework on this tonight, guys. It should be pretty simple. Please make sure you get it done and read your announcements and make sure you know what is due for next class period. All right. Sorry to keep you a minute late. Thanks for your patience today.